There are a lot of very different things that I'm interested in and that I like to work on. But one thing that particularly fascinates me about older quality tools is that they can teach us much more than the casual observer would see. The story behind their production is also a story about a more localized economy, aiming for products that would last and that would essentially fulfill a real-world need for as long as possible. And the people who made these objects probably gained a sense of meaning through their work, which almost seems like a luxury in this day and age. And last but not least, by inspecting items designed to meet the aforementioned standards, we can learn some engineering lessons that are basically timeless. Today I once more searched through a scrapyard to find items to reuse, repair and repurpose. So let's see then what we can find here today. Crushed by this huge trailer here, we find a Siemens brand ultrasound machine, probably from a hospital. The base unit is clearly ruined, but the ultrasonic probes here can easily be detached. You don't want to know where they have been before, but even though they might be 20 years old, these are still worth a pretty penny. There are probably also people who could make use of the trailer, but that's out of my weight class. This looks like a plate compactor, but the most important part, namely the engine, is missing. A bunch of transformers, some 3-phase, some single-phase. Actually not a bad find, but I have learned to keep my hands from really heavy equipment if I don't have a concrete application for them in mind. And in this old bathtub here I just found a small brushless blower made by IBM Papst. This one I will also buy. An old rusty table saw. Could maybe still be interesting for making firewood, but I already have one of those. This one, on the other hand, is a pretty cool find. A pump made by the Steel Pumps Corporation. Very valuable part, and this one I'm going to buy as well. A huge bench grinder, but unfortunately it's not for sale. But here is another great tool that I have gotten my hands on, and I have already loaded that into my trunk. A nice old drill press. Another item that we're having a look at in this episode is this ancient power drill here that a friend gave me a while ago. I'd say let's go to work then. Let's repair this drill press then. When I first saw it, I could tell right away that it is something special, well worth restoring. It's a pretty old model, made obvious by the fact that it uses a flat belt with just a minimal guard in the front. Once it's restored, you'll see that it is a thing of beauty, but also a case study in classic mechanical engineering. Taking this apart and putting it back together again will show us all necessary components for a minimalist approach to drill press design. And who knows, maybe some of you will get ideas for a DIY drill press here. It was made by AEG, and behind the Siemens Corporation, AEG used to be the second biggest producer of electrical equipment in Germany until its eventual dissolution in the 1980s. After being in business for about 100 years. And I'll talk a little more about AEG in just a few minutes. First, let us take a closer look at the drill press itself, assess the damage, and lay out a plan for its restoration. The old flat belt has seen better days. I can still move this feed lever, but only with considerable effort. The quill is almost stuck because of dried up old grease and dirt. The column is also very rusty, with the table and table lock lever, or lever, depending on where you're from, locked in place. It also needs to be cleaned and greased to make the table height adjustable again. The motor is a 3-phase induction motor, and the power cord has a 3-phase plug for 400 volts, 16 amps, 3-phase power. The wire is severely damaged though and needs replacement. This is a rotary switch for the motor. The old plastic knob is missing though. The old paint job is in a pitiful state, and I will have to renew that as well. Let's get it done then. After pulling out a small pin, the belt guard can be tilted down and the flat belt can easily be removed. In order to be able to detach the motor, WD-40 is applied. In fact, it is applied to many parts of the machine, like the column, base and quill. In short, anywhere where old grease or rust will have to be removed. After unscrewing these two bolts, the motor can actually be pulled out rather easily. A massive 35mm steel bar was used here to connect two parts and put tension on the belt. This lock lever is stuck, and I'm using a plastic hammer to get it loose. And after the WD-40 has done its work, the table can be pushed down, revealing more rust beneath. The feet lever is also supposed to be adjustable, but is stuck in one position. It receives the same treatment. For the moment, I'll leave it in this mid position so that the quill can be moved up and down more easily, and it actually already is much easier to move. This part here is a depth stop or limiter that can limit the range of motion of the feet and thus the maximum depth of your drill holes. But at some point in the past, a small piece has broken off. This little bolt has a double purpose. It is a stop for the limiter and also holds the gear inside the feed mechanism in place. Here on the side is a second bolt that does that as well. Both need to be unscrewed to clean the feed from the inside. But I frankly had it with all the rust and dirt, so let's start to remove it with a wire wheel and an angle grinder. Since there is a lot of dust flowing through the air during this process, it might be smarter to open the feed only after this is done. While I'm at it, let me tell you a few more things about the manufacturer. Now, I said that AEG was dissolved in the 1980s, but then some of you have probably seen AEG branded products somewhere in a store. Well, that's basically just fraud. As with many other German companies that ceased to exist, the names of those companies were sold and are slapped onto products to this day, the production of which had nothing to do with the original company. Some more fun facts. AEG stands for Allgemeine Elektrizitätsgesellschaft, and that basically means General Electric Corporation in German. In the very beginning, the company was also called the German Edison Company, because it used some of Edison's patents for production here in Germany. This company is no more, but I own a number of AEG power tools running to this day. For example, my other drill press that I repaired in a video just a few weeks ago. With the rust and most of the paint removed, I have now started to drive the gear of the feed mechanism out of the frame of the machine. The quill had already been taken out. I normally wouldn't even recommend to take a mechanism like this apart, because there's a chance that you will ruin it. But the old grease on this gear is basically like the nastiest type of glue that you can imagine. I'm scraping it out with a small screwdriver, but that's not good enough to clean it properly. For really tough cases of old grease, I sometimes revert to gasoline. In my experience, there is basically no better solvent for this type of grime. But please do not work with fire or an angle grinder or anything like that next to an open container with gasoline in it. While the grime is dissolving, I'm taking care of the insides of the feet. I use WD-40, abrasive fabric and steel wool for that. It is fun to look at even a simple part like this, because you can tell how it was made by classic metalworking techniques. The frame was cast from cast iron in a mold. Cast iron is used for machine beds, supports and frames because it dampens the vibrations better than a steel frame would. The cast was then drilled, bored and machined to house the gear and quill, etc. Wonderful stuff. With the gear cleaned, I put it back in, and this should be done with a tool softer than the steel of the part itself, hence the aluminium hammer. I'm now also putting the quill back in, and of course these parts need new grease now. In the meantime, I have used some tape to prepare the drill press to be repainted. The parts that I now spray paint have also been prepared, by first wire wheeling them, then degreasing them with paint thinner and some rags. After the paint had some time to dry, the tape is removed and everything is reassembled. The pulley is put back on, so is the motor and the feed lever. I also strap a new replacement belt onto the machine, even though I later learned that the old belt was still working okay, and I will actually use that in my first test here. Now this box on the side of the motor was opened and the remains of the old power cord removed. The wires leading in the motor are ancient as well, of course, but would be much harder to replace. But they are not brittle and seem to hold up just fine. So I just attach a new power cord and plug. And here is a little before and after comparison. This is what it looked like before I had started working. And this is what it looks like right now. I don't often work with paint, But when I repaint really old machines, I often use this shade of gray, which is or is close to RAL 7021. I rarely sand the cast iron surfaces to a shiny silverish tone, but leave them at the raw cast iron look, which is also more resistant to corrosion. So I'm really happy to see this beauty running again. It looks a little shaky in some of the footage here, but that's just because it's not yet bolted down. I for one hope that you will see it return many times in future videos. Let's have a look at this pump then. The manufacturer is called Steel Pumps, and this particular model was apparently made in Italy. So my greetings go out to all the viewers over in Italy. It's a pretty expensive unit with a whole array of possible applications, and I wonder why this ended up on the trash. It can't be particularly old, and like so many times before, my job begins with superficial cleaning of the object. Some people might find that unnecessary, but I can't say it too often. When you clean something by hand, you can often find damages that you might have overlooked otherwise. Steel wool and WD-40 in combination do a great job here, by the way. Because the power cord has been cut off, and since I need to know if water has maybe leaked into the electronics, I need to remove this stainless steel cover. It's simply held by a number of screws. Inside we find a white motor capacitor for the induction motor and also a black plastic enclosure holding a small PCB. What does it do? Well, this datasheet states that this pump includes pressure control, an anti-blocking system, leak detection, and anti-dry run protection with automatic restart. This PCB has obviously a transformer and a small relay that can probably just switch off or restart the pump if any of the aforementioned fault modes occur. The circuit can measure the flow rate of the water by means of this little rotor here. I don't know if you can tell from the footage, but there is a little magnet in there that is attracted to my screwdriver. There must be a Hall sensor in there as well, maybe on the PCB, and by means of that Hall sensor, the circuit can measure the rotational speed of this rotor. If it runs faster, the magnet will pass the Hall sensor more often, and that's how you can derive the rotational speed or then the flow rate, etc. I can, however, find no damages or water in here, so I simply install a new power cord, and I bought some 1¼ inch thread hose barbs, and I connect a 32mm hose to it, held in place by a large hose clamp. To make it easier for the pump to draw water in the first place, I put it into this bucket here. And for a long-term test, I allow the water flow to go right back into that bucket. So far, I could not find any fault whatsoever. On to the next item then, this brushless DC fan. It was made by EBM apparently in the 26th week of 1996, so it's not exactly new, but still looks pretty good. It once probably had a plastic cover that is now missing. Looks a lot like the little brother of a blower also made by that company we looked at in the last episode. By the way, this is the 14th episode of this video series. All other episodes can be found in the video description below. I simply soldered 2 wires to the pads on that PCB, and I'm connecting them to these two 12-volt batteries that are connected in series. In this case, I can also find no faults. Maybe whatever it was installed to was decommissioned, so the fan ended up here, even though it works just fine. And here is the power drill that was given to me a while ago. A really ancient piece that looks almost like cyberpunk to the modern eye because of its unusual design. It actually has a brass nameplate stating some basic electric ratings, and there is a logo on there as well, but I don't recognize it. Incredibly, this is the on-off switch of the drill. The chuck of the power drill is a two-jaw chuck that you have probably never seen before. Here's a picture of the first electric power drill in the world, built by the Fine Corporation in Germany in 1889. Now, our machine here is certainly somewhat newer, but it has the same type of chuck. I start to open the enclosure and the first thing I remove is the handle. Inside, we find remains of what probably was the original paint job, of which is apparently nothing left on the outside. And under these wonderfully thick brass caps here, we find the motor brushes. They are cylindrical, which is unusual these days, and believe it or not, there is still some meat on there. While opening this brush holder, I managed to break off a wire that I will have to resolder in a minute. Upon taking the cover off, I found one of the most archaic switches I have probably ever seen. Everything here is more massive and uses way more material than any modern component. I don't see a lot of wear or burn marks on the switch though at all. Upon unscrewing the front of the power drill, we can inspect the insides of this reduction gear. Inside is nasty old grease that I will replace entirely. I start to wipe it off with a paper towel, but other methods will be needed here to remove it entirely. You could try to pull this gear off its axle, but as I said before when repairing the AEG drill press, sometimes you should just leave it be. Now I pull this cover off the stator housing, removing the armature as well. This is actually quite similar to many modern power drills, where the armature of the universal motor comprises one unit with a part of the reduction gear. This also allows us to look inside the stator, where I can see no obvious damages. Both parts of the reduction gear have nasty grease inside, as well as an incredibly resistant grime on the outside. There is no chance to get that off with rags or detergents of any kind. Just imagine the old grease burned into an ancient frying pan. Only strong solvents might help. So let's make this an experiment. I submerge this part here in WD-40, not touching the electrical components, while I place the other part next to it, but this time submerged in ordinary gasoline. And now we have to wait for a while. Just on a side note, I'm using WD-40 all the time here at the moment, but that's mostly because I bought a canister of this stuff recently for a good price and it works for what I'm doing here. I have no affiliation with them whatsoever. They are paying me nothing, and I'm also not saying that their products are better than those of their competitors. Actually, this channel is only financed from YouTube revenue and private contributions. Many of my supporters use Patreon for that. I seem to be one of the last channels this size who has so far not agreed to any advertising deals, even though I get several offers every day. I only would do advertising for companies whose products I really enjoy, but I'd rather prefer to keep the channel completely independent. If you want to help with that, maybe consider becoming a supporter on Patreon as well. There's a link below the video. After just a few minutes, the gasoline has already dissolved much of the grease, and we can easily wipe it off. The WD-40, on the other hand, works much slower. It does work, as you can tell by the darkening of its color, but slower than gasoline. On the other hand, it is much less volatile, and you don't get so dizzy from its fumes. To get inside every nook and cranny and remove what's left, I first use steel wool, then a small paintbrush to get rid of the remaining grease. The handle is then cleaned the same way. The brush connector is repaired. New grease is put into the gearbox and also into the ball bearing. And front and back are eventually bolted back onto the midsection of the drill. I have now temporarily clamped the drill into one of my vices, and I have connected the motor directly to the isolation transformer for a first test. And it obviously runs. In the next step, a new power cord is installed and the cover is screwed back on. I use a piece of sandpaper to remove the rust from parts of the chuck, revealing the name Ixion on it. Now Ixion is or was apparently a manufacturer of power drills and drill presses, so I guess that there is a good chance that not just the chuck, but also the drill itself was made by that company. Unfortunately, I have not managed yet to find out more about them. If you have information about Ixion, please comment below. In order to remove the rust from the upper part of the chuck, I first want to screw the worm screw further in, but none of my screwdrivers or keys fit, so I decided to grind down this spare Allen key here. And then the cleaning of the midsection went on and on, until it was finally time for a real test. So as always, I hope that you liked this episode, and if you did, then please give this video a like, giving me the clear sign to go full steam ahead with the production of more videos of this type. And if you want to support this channel more actively, there are several options that you can find down in the video description, like Patreon or PayPal donations. See you soon.